Hello guys, my name is Anushka Tomar. Today in this video, I'll be showing you logistic regression modeling in data science. Here we will also learn about logistic regression and Poisson regression. Now let's see. In this video, we will discuss how to perform logistic regression using Python, how to perform Poisson regression using Python. Now first, let's talk about what is logistic regression. Here logistic regression calculate the chance of something happening. Means while, for an example, India won the match or India won the toss or not, if we are tossing a coin, head comes or not. So it has two binary outcomes. That is yes or no, 0 and 1, true or false. Now what is Poisson regression? Poisson regression predict the number of times something happened. Means, for an example, how many person has what TB in a day, how many accident occur in a day. In simple word, it will calculate the chance of something happening, or it calculate the number of times something happens. Here, let's see an example. Here we are predicting a weather. A customer subscribe to a service based on their age and salary. Here we have data set. Age is equal to 25, 30, 35, 40, and their salary is 50,000, 60,000, 70,000, 80,000, 90,000. We are checking whether they have subscribed or not. 0 for no and 1 for yes. These are our two binary outcomes. Here 0, 0, 0, 1, which is telling about whether a customer subscribe to a service based or not. Now here, this is an example of Poisson regression. Here we will predict the number of accident based on the number of days worked. Here these are the days worked and the accident. These are our accident. Here what we are doing, we are predicting the number of accident based on the number of days worked. So it's all about logistic regression and Poisson regression. Now let's see the code of logistic regression using Python and Poisson regression using Python. Now we will see code for logistic regression using Python. Here we have imported some library that are pandas, train, test split, logistic regression, accuracy score. So here panda is used for creating and manipulating the data in a table like structure, and the train test split, that is from sklearn dot model selection import train test split. It imports a utility to split the data set into training and test set. Here we have also imported sklearn.linear model import logistic regression. It imports the logistic regression model from scikit-learn. Now for the library that we have imported is accuracy score. It imports a metric to evaluate the accuracy of the model's prediction. Now we have created a data set. Data is called to pt.dataframe. pt.dataframe is used to, to convert this data into data frame, that is a table like structure. Here we have taken age and salary are the input feature, and subscribe is the target variable. 0 not subscribe, 1 is for subscribed. Here x is equal to, here feature age, salary and target subscribe. Here age and salary extract the input features ages and salary into a variable, and here x y is equal to data subscribed extract the target variable subscribed into a variable y. Now we will split the data into training and test set. 80% of train and 20% of. So here we have written x train, x test, y test is equal to train test split x y test size 0.2, random state 42. So here train test split the data into training and test set. So here 20% of the data is here, test size is that is 0.2. So here 20% of the data is allocated to the test set and 80% of data training set. Now here random state is 42, which means it ensures reproducibility by using a fixed random seed. Here we have written X train and Y train. What does it mean? It means training data used to train the model, and here X test and Y test, it means test data used to evaluate the model. Here now then we will create and train the logistic regression model. Here we have written model is equal to logistic regression, which is initializing the logistic regression model, and then we have used model dot fit x train and y train that train the model on the training data set x train and y train. Now we will make the prediction. So here prediction is equal to model dot predict x test. That make prediction on the test set of test and store the predicted value in ypred. Now we will evaluate the model accuracy by using accuracy matrix. Here accuracy square is under bracket we have written y test comma y predict that compare the two levels y test with the predicted level y pred to calculate the model accuracy. Now we will print the logistic regression accuracy. Here it will display the accuracy. Then prediction for test set. Here we will print or display the predicted level for the text data. Now let's see the output of this code. Here what output we get. Logistic regression accuracy is 1.0 and prediction for test set is 0. It means it means what does it mean? It means our accuracy is 100%. That indicate the model perfectly predicted the subscription status of the individual in the data test set. This is likely because the data set is small, simple, and linearly separable. That is, the classes can be clearly distinguished using the input feature. And here, our prediction for test set, that means predicted output is 1. That indicate the model predicted subscribe to the individuals in the test set. This test set contains one row because the data set is small and 20% of 5 sample equal 1 sample. So this is the output for our logistic regression code. Now we will see the Poisson regression code. Here in this, we will predict the number of accidents based on the number of days work. For this, we have imported library pandas and state model API as example. So here, panda is used for manipulating data and state model is used for provide statistical models and methods, including Poisson regression. Now we have created a data set. Data is called to pd.dataframe, which as we know, pd.dataframe convert our data into table form, table like structure. Here we have taken day worked 10, 20, 30, 40, 50. This is the day worked and accident for 10 days, one accident, 22, 34, 46 and 58. Here, day work is an independent variable that representing the number of days work, and the accident depending it is a dependent variable that representing the number of accident observed. Now, features x days work and target accident. So here, x contain the independent variable days work and y contain the dependent variable accident. Now, add a constant term to the model for intercept. So here we add a column. What we have to we add a column of ones to x to account for the intercept in the regression model. Without this, the model would assume no intercept. Now we will create and train the Poisson regression model. There we have written Poisson model is equal to sm dot glm y comma x comma family is equal to sm dot family dot Poisson dot fit. Now let's see the use of these all methods here. SM.glm, that is generalized linear model, is initialized for positive Poisson regression. Here y is equal to target variable accident and x is equal to independent variable, that is they work with constant added. Now here the family is equal to sm.family.Poisson, which is specified that this is a Poisson regression model. And here fit that train the model by estimating the relationship between day work and accident. Now here this is our model summary. We will display the model summary by using print method. Here dot summary provide the detailed summary of the regression model, include the coefficient and prediction and static mass rate values, etc. We will see the output. Here we will make prediction for all data points. Here we have written prediction is equal to Poisson model dot predict x is what it is number of days worked. So here it predicts the number of accident for all data points using the trained model. So now we will print the prediction. Let's see the output of this code. This is the output for our Poisson regression code. Here this is a const, this is a day worked, coefficient, standard error. Now the interpretation is the model predict the expected number of accidents for each value of days work. So here for 10 days it predicted accident to 2.133. For 20 days it predicted accident to 3.04. For 20 days it predicts accident 3.47 and so on. Here our data type is float 64. So this is the output of our code. It's all about logistic regression and Poisson regression. So here that's it for today video. Now I'll see you in the next video. Thank you for watching my video.